Hello everyone, welcome to Ebasiq video tutorials, your go-to place for mastering AI, Python and computer science concepts. I'm Chandagrish. So in today video, we will discuss on sorting algorithms, merge sort as quick sort. Okay, so we will understand the key sorting algorithms for practical efficiency. So if you see uh, why we need sorting. So sorting is a fundamental operation in computer science, as we all know. So sorting is used in searching, data processing, optimizing storage efficiency, and in real world use cases, we use in e-commerce where we sort products based on price, ratings, and in databases as well. There we use for query optimization in indexing and also in computer graphics like jet buffering to determine the visibility, and in genetics, DNA sequencing in bioinformatics we use. So MedSort, how it works? So MedSort follows the divide and conquer approach. It recursively splits the array into halves, okay, and then sorts them and merge them back. For example, sorting arrays 63852741. So would first split into two parts. Okay, sort them individually and merge the sorted halves. Okay, so basically divide means splitting the array into two halves recursively here, and conquer means sort the two halves separately, and finally merging means the combined sorted halves into a single sorted array. And here the time complexity, the best case, worst case, and average case, order of n log n, and stable algorithm. So maintains the order of duplicate elements. Now, if you see the quicksort array, so here quicksort is a partitioning algorithm. So we select a pivot and divide the array into two, one with elements smaller and another with elements larger than the pivot. Okay, so it works efficiently on in place sorting, but can degrade to order of n squares in worst cases when the partition is unbalanced. Okay, so basically we need to choose a pivot, last element are the randomized, partitioning, rearrange elements so that smaller ones are on the left and larger ones are on the right. So we will recursively apply the quick sort on the subarrays. So if we take example sorting 63852741 using 4 as a pivot. So we are partitioned into 3 to 1. So the pivot is 4. So 6857. Recursively sort left and right subarrays. Okay. So we will see with an example in just few minutes. The time complexity, best case and average case, order of n of log n, and worst case is order of n square, which is in unbalanced partitioning. So if it is a non-stable, not stable, then may not preserve the order of duplicates. So performance comparison. So we will see with the code, then we will understand better. So sorting algorithm, merge sort and quick sort, best case will be order of n of log n, both cases, and average case order of n of log n, worst case order of n of log n, and then order of n square, worst case for quick sort. So stable mid sort, yes. In place, no. And stable quick sort, no. In place, yes. Okay. So we'll see how this will work. So overall, I'm going to explain the step-by-step code how to implement the med sort and the quick sort. So first we will generate a list of random list of 10,000 numbers, random list of 10,000 numbers, and then implement the merge sort. So we will use the divide and conquer and recursively divides and merges the arrays. And then we will implement quicksort by partitioning and recursion. So using the pivot to partition elements. Okay, and measuring the execution time for both the algorithms and displaying the results. Okay, so now we will see step by step. So here in case step 1, what we are doing, um, we are importing uh, random, so which is used to generate a list of random numbers, and then importing the time which is used to measure the execution time of sorting algorithms. So in that first step we have to do this, and in the second step uh, we are uh, defining the merge sort function. Okay, so merge sort function. So here def merge underscore sort, we are passing array. So if our length of array is less than or equal to 1, we are returning the array. Means if the array has 1 or 0 elements, it is already sorted. So return it as is. Okay, and then we are trying to find the middle index. Okay, so that is mid equal to length of array floor by 2, floor division of 2, and left we are recursively dividing the array into 2 halves. Okay, so left half will be first half of the array, and then right half will be second half of the array. Okay, and after that we are uh, calling return merge, uh, returning the merge left half and right half. So this will calls the merge function to combine the sorted left and right halves. Okay, now we are defining the merge function. So in merge function, first sorted array, we sorted underscore array we are taking is an empty, which stores the final sorted elements here. So initially I, j, these are the pointers to track elements in the left and right arrays. Okay, and so after that, what we are doing, we are writing a while condition. So here this iterates over both hops and compares the elements. The smaller element gets added to the sorted underscore array, and the pointer of the selected element like I or j is incremented. Okay, and after that we are adding the sorted array dot sorted underscore array dot extend to left and right. So means we are adding any remaining elements in the left or right if one list was longer. Okay, so it returns the merged sorted array. Okay, for example here if you take here 563852741. Now if you divide this 6385 and 2741, and further if you divide it, okay, 63852741, now you sort it and merge. In this case, you have to sort it 36582714, and then after final merge, we'll get a 1234567 8. Okay, so this way, that's how merge sort will work. Now we will see the implementation of quick sort. Okay, so here in this case, we have defined the quick sort array. Okay, and if the array has 1 or 0 elements, it is already sorted. Now we are taking pivot, means the last, we are selecting the last element as the pivot. So that is nothing but array of -1 index. Now we are doing partitioning left right. Okay, so left to right, left elements smaller than or equal to the pivot, and right elements elements greater than the pivot. So finally we are returning the quicksort recursively sorts left and right subarrays, and it concatenates the left plus pivot plus right. Okay, so finally we will return this. Now how quicksort works, if you see, sorting 63852741 with a pivot 4. So we are partitioning 3 to 1, that is left, pivot is 4, and 6857, that is right. Now recursively sort left and right. Now left is 1 2 3 and right is 5 6 7 8. Now finally sorted array will be 1 2 3 4 5 6 7 8. Okay. Now what we are doing, step 4, we are generating a random list. So here array size is, we are taking 10,000, and array Actually, we are creating a list of 10,000 random numbers between 1 to uh, uh, 1 to 100,000 numbers. Okay, so we are generating a random list. Now, in the second step, sorry, fifth step, we are measuring the execution time. So we are actually recording the start time. We are calling the mid sort by passing the array and then computing the elapsed time. Okay, and then we are repeating the process for same for quick sort as well. Okay, and then now finally in the step 6 we are printing the execution times. So printing the mid sort time and quick sort time both, it displays the execution time of both the mid sort and quick sort. Okay, so this is the complete implementation of the code. In above I explained step by step, so this is the completion, complete in full code. So if you execute that, then we will get a mid sort time 0.0229998 seconds, and quick sort will get 0.026007 seconds. Okay. So in summary, uh, so real world applications where mid sort is used, sorting large data sets, used in external sorting when data is too large to fit in the memory. Also, it will be used in stable sorting, which is used in databases where maintaining order of equal elements is important. And linked list sorting so works well with linked lists as merging can be done very efficiently. And similarly, where quick sort is used, like in memory sorting, like language like C, Java for quick in place sorting, and we also use in competitive programming, for most average case scenarios, and database and search algorithms also, which is used for query optimization. Okay, so now this is what we understood. So metsort is best when stability and worst case, that is order of n of log, are needed, and quicksort is usually faster in practice but has order of n square worst case complexity. So we have to use the right algorithm depending on our data set size and constraints. Okay, so this is the about the medsort and quicksort. Hope you enjoyed this video. See you soon in the next upcoming video. Thank you.